Okay, well, welcome aboard, everyone. This is our grade 6 space unit, and it's our last unit for science altogether. You've covered everything that there is pretty much, at least the first time round, in covering space. So welcome aboard. My name is Chris Arski. I am one of the consultants with the ARPDC, working basically with CARC. And I have the best partner in the world for doing science with, and I'll let Ted introduce himself.
Thanks, Chris. Good afternoon, everyone. My name is Ted Zeroni. I am uh, designer of professional learning with the Edmonton Regional Learning Consortia. It's in the capital region. Welcome to today's session. Thank you for taking time to be with us. And as Chris said, it's a long one, so we'll get going here.
You bet. And there's a few links in here that we didn't start on this one just because of time and interest of time. So we're going to be a little bit careful. But there is, for those of you who are Star Trek fans, a little bit of a hidden link in this blue circle that you see up here. So you feel free to share that with the kids. I think when they hear the music, especially if they're old Star Trek fans, as this person is, they might find a little bit of humor in that as well. So before we begin our acknowledgement, we are dealing with star science and the celestial bodies that are up there. So again, as we have been all the way through, trying to link whenever we do the land acknowledgement, something that is related to the organizing idea. And in this case, it's a sort of an offshoot of what they've been doing in grades 4 and 5, and that is the legends and the stories that go with the star science and how some of those stories and legends actually informed actual practice as far as timekeeping, as far as moving around, following food, knowing when seasons were going to change, etc. So the story that when we won't go into it right now, it's a very short one, but it's a 2-minute sort of story that Wilfred Bruck will talk to you about the night sky, and he has several of them on YouTube, so feel free to go and Google him if you need more. There's also other links in this slide deck to kind of fill that gap in. We know that star science has always been in grade 6. It has now been stretched from grades 4, 5, and 6, and each one of them are quite unique in building up to where you are in grade 6. So for those of you who are new to the science program, the students won't have the background language and vocabulary that they would have acquired in grades 4 and 5. So there will be a need to go back and do a little bit of refresher there and teaching. But again, depending on how you structure this particular grade's organizing idea, you'll be able to sort of select from each of those grades what it is that you're going to need to go back on. So in the spirit of reconciliation, we want to acknowledge that this gathering is taking place on traditional lands across the province of Alberta, home to many diverse First Nations, Métis, and Inuit peoples. We acknowledge that this land is a traditional meeting ground, giving voice to its original peoples and the story of creation of this country in a way that history has forgotten. So we will sort of go back very briefly over, because some of you will be new to watching the science videos, and this will be the first one. Space is kind of a popular one for everyone. So we recognize that some people have not been joining us all the way along. So we're going to take a little bit of a review step, not the whole thing, but just be patient with those who haven't heard it before. Okay, and I'm going to turn it over to Ted.
Thanks, Chris. Just a really brief introduction to the new curriculum again and comparing it to the old one. As we know, the old curriculum, if you've taught it last year and we're teaching it this year, we know that they're broken down to topics, and they are all broken down to topics right from grade 1 to grade 6. And those topics were fairly independent. They stood on their own. We studied the topic and then we moved on to the next topic and so on. And every teacher did that in every grade without much connection in between the two, as the metaphor of the grain silos in this image have. With the new curriculum now, that changes somewhat. We have silos, but they're not disconnected anymore. And that big connecting piece are those organizing ideas. So for example, we're taking the organizing idea of space. Space is something that if we learn some things and move on and bring that forward into grade 4, into grade 5 and grade 6 and so on. And not only do we move forward some of those knowledge pieces and those skills from space into other grade 6 organizing ideas. They're also spread around throughout the grades. So some of the ideas that are taught in elementary matter and energy and earth systems are brought forward and are referred to and are used in understandings in the older grades, including grade 6. So we got a lot of movement back and forth between the concepts, skills, ideas, and the understandings between the grades. And the next slide just identifies that exactly. That. It's the knowledge and the skills and understandings particular that move back and forth. So let's just take a quick look at what are that we'll go to the next slide. This is the wrong slide, I think. We're going to actually just go on to the next slide, Chris, and begin with what is it that students need to know. Remember, the knowing part is basically got 3 things in it, that knowledge column. It's got facts, which are just pretty much names, dates, and information like that. Or in this particular case, that the Earth revolves around the sun is a fact. There's those concepts such as star, constellation, prediction, so on that are in that knowledge piece. But there's also skills and procedure knowledge in that first column. For example, if we take a look at computer science, what is the steps in design thinking? That's identified in the knowledge piece. And same with the investigation in grade 6. We have to look at the knowledge piece in grade 2 that identifies the steps. So all that's included in the knowledge piece. And it's all ties together, especially the concepts, which show on the next slide, which shows some of the progressions from grades 4 to grade 6. As Chris mentioned, knowing some of that, knowing what the students took in grade 4 and grade 5 is important because they're probably not coming to you this year with that background information. So here's what they're coming in with. And if you, or with some things you may have to back up and help students understand. And I'm going to express it in this concept map. And it's going to begin at the top where we talk about the universe includes space and everything in it, including all the objects. We're now in the center of the concept map. And we can examine and view those objects in space through different tools, such as those presented there. The objects that are looked at in grade 4 specifically are the stars, planets, and moons, and more specifically, the constellations in our moon. And then we take a look at not only what the constellations are, but and the moon and those things in space, but what impact do they have on us? For example, navigation and time and so on. We build on that in grade 5. And what we add on is the idea of astronomical phenomena. And those, again, are events that we see in space. So we're not focusing so much on what the objects are, but the phenomena, their movement up there. So we have examples of the moon phases as a phenomena, astronomical phenomena. We see seasons and the auroras and so on. And those are the things that are investigated in grade 5 and how they impact us. When we get to grade 6, you'll see that some things change. The idea of objects in space changes to celestial bodies. So now we're using that idea. And we add on 3 of the celestial bodies. We add on meteoroids, dwarf planets, comets, and asteroids. We also take a look at stars and our sun, planets, and the different moons. You'll notice that the celestial bodies are really identified as components of a system, in this particular case, the solar system. And I want to point out the idea of system I'll focus on a little bit later, because, and in this organizing idea, we also gain knowledge about the solar system, and we find out that we gain that knowledge through technology, discovery, and exploration, and so on of outer space. So that, in a sense, is grade 4 to 6 the ideas and how they're connected and how they're developed in those grades. And I'm just going to have you go back one slide a little bit. Just go back to that slide. I just want to point out that quote. And I point out this quote because I think it really reflects the nature of where this organizing idea and the other ones are going, and that it's that grasping the structure of a subject, and other how things are related, and understanding it in a way it's many things to be related to it meaningfully. We can connect Earth systems onto this if we really understand the structure. And so to learn the structure in short is to learn how they're related. And unless we take time to pull these relationships together for students and help them gain that understanding, those relationships and that structure of the subject, is hard for them to do it on their own. Thanks, Chris. We can go to the next slide. That's the knowledge piece. Skills procedures are identified here. We've got 2 tables here. The one on the right is the conglomerate of all the the skills and procedures that are mentioned in grades 4 to 6 science and all the organizing ideas. There's a frequency distribution on that right-hand table that identifies the most frequently used verbs. There, discuss, you could see by far it's more than the others, relating, comparing, investigating, examining, explaining, and so on. Those are the key ones from grades 4 to 6. In grade 6 space, the key, or grade 6, not space, but grade 6 period, we'll see there's a similarity. Discussing, investigating, comparing, relating, describing, representing. Those are all key skills that happen in grade 6 science. So we're going to just keep that in the back of our mind, because if you take a look at all those skills from 4 to 6, they help us to do something, especially when it comes to the assessment piece. And I'll give you an example on the next slide. Oh, maybe not. I guess, did we, no, that's all right. No, it's coming back to another slide. We'll keep going, Chris. So
Okay.
there's all those skill verbs identified in the skills and procedure, but there's some other verbs that need to be brought up into grade 6. One of the things that happens in grade 6 is investigating. And you're not going to find the steps in scientific methods in grade 6. You have to go back to grade 2. And that's what this graphic shows. Those 7 steps are identified in grade 2 in the bottom left-hand corner. And what happens in grades 3 to 6 after that is there's different information and a deeper plunge into some of those steps happen at the different grades. The last step of explaining and discussing happens in grade 6. So that's where we take a look at what's a good explanation? How do we bring evidence to make a good explanation using things like representations and bring in our hypothesis and the evidence into that whole explanation. But when students are asked to investigate, they still need to go back to this grade 2 piece and follow those 7 steps. Besides the skills and procedure statements, we have all those verbs and the scientific methods. We also have a lot of skills in computer science. And this is a quick breakdown. We know that in kindergarten to grade 1, the focus of the skill is focused on is creating instructions. And it becomes important to grade 6. I'm missing the grade 6 there, because one of the things that students need to do by the time they're in grade 2 and up into grade 6 is to design their own experiments or investigations, which is really a series of instructions that they have to create. Grade 2 students are introduced to creativity, and creativity is identified as originality. There's a slide to help you introduce originality if you want. Grade 3 also focuses on creativity, working more towards divergent thinking. How do we get students to create original ideas? And there's a click on there for divergent thinking for some techniques that might help with that. In grades 4, 5, and 6, we move on to, and introducing grade 3, we're talking about computational thinking and design thinking. Both of them are problem-solving methods, but again, a skill and procedure that students can do to demonstrate what they know. The next few slides, I won't go into them in depth, but they just identify those things that if we'd had the K to 6 moving forward, students would be coming in with knowledge about computational thinking. There is a clicker there to help if you want to introduce computational thinking to your students. Next slide, in grade 4, we're talking about design thinking. Design thinking is another problem-solving technique. Some of you may have heard creative problem solving. This is similar to that process where you focus on the problem, form ideas, make a plan, you create it, you analyze it, you test it, you troubleshoot, and it's done. And so that design thinking can come in handy at every grade level when you're doing any kind of project where you're doing that planning and designing ahead of time. And finally, grade 5 and 6. 5 is a closer look at computational thinking, again, more specifically creating artifacts. And grade 6, again, comes back to that computational thinking and talks about the creation of abstractions. And so each of these problem-solving techniques of computational design thinking can also be thrown in and not just used within those organizing ideas. And that next slide will show you what I mean by that. So if we were to take a look at one of the statements from the space organizing idea in the first cusp, it reads that were to classify celestial bodies of the solar system as planets, moons, dwarf stars, and so on. The emphasis is on classify. However, we can, if we're doing an assessment or we want to do an alternate activity, we can take those same ideas of the celestial bodies, but have them do something with it. Instead of classifying, we can have them compare. Or we can take a scientific method skill of investigating and they can investigate or do an experiment with something. Or if we could take the computer science skill and they can plan something or design something related to the celestial bodies, whether it be designing a model, planning a representation, and so on. So all these skills are there available to us to use, to build, to help students deepen their understanding. And again, at the end of the day, we can use any of these skills to assess student understanding and knowledge on these areas. And finally, that understanding piece in grade 6 in this cusp, we have 2 understandings. And this slide's there just to remind us that each of those understandings are built from the knowledge. We have the knowledge, and that understanding takes those key concepts from the knowledge and organizes them in a meaningful way. So we're to take a look at solar system, information, Earth, and exploration as key concepts in the knowledge piece. If we go to the next slide, we'll see that it's put together in an understanding. And that's the second understanding there, that knowledge of the solar system continues to develop with further exploration, discovery, and use of technologies. So the 2 key understandings here is that we gain our understanding of the solar system by exploration, and we can also gain the first understanding that we can also get information about the Earth through exploration of the solar system. And I just want to take a pause here and just a warning that this organizing idea can be a whole lot of facts. There's lots of information about all the planets, the celestial bodies, about exploration technology, and so on. And it could become a very huge, I guess, bin of facts. And unless we take the time to organize them and present them in a way where students can relate these things to other ideas, it's just going to be a lot of facts. And I just want to point out that one highlighted part on this slide. And I think it really hits to the heart of this organizing idea. And to understand the heart of that, I'm just going to follow that arrow up to the top part. You'll notice that the statement for the organizing idea of living systems, Earth systems, and space are worded in the exact same ways. And it reads, and I'm going to read this out because I just want to draw your attention to it. Understandings of the living world, Earth, and space are deepened by investigating natural systems and their interactions. So in all those living systems and Earth systems, we're looking at the interactions within those systems. And if you take a look at the knowledge piece, that one knowledge piece is the only one that really hits that nail on the head. And it reads that scientific exploration of space has revealed that Earth is an interconnected part of a group of planets in the sun. So that really speaks to the whole idea that we're looking at how systems are, that systems have components and they interact. And it's the understanding of how that system interacts in the components that I think is really the heart of this organizing idea. So that we have to be careful not to necessarily just focus on all the facts that are in here, but how they're organized together and how they work as a system and have some kind of interaction with Earth at the same time. So the way we're unpacking this is by doing that backwards by design, or planning by design, working backwards with the end in mind. And I'm going to begin by providing maybe one assessment piece that may be used as a summative assessment. Just to show that if we take a look at our summative assessment and do it properly, we'll need to back up and make sure students understand some things. So if I were to have this assessment to create a representation that helps explain how the solar system can be considered a system, that becomes a fairly deep assessment. And we have to back up and think, what is it that students need to know and to able to do in order to be successful in that assessment? There's a second sample there, and maybe that could be used as well. I won't get into that one. My focus right now is that first one, but we could compare an Earth, the solar system, and the Earth system and say, how do those two systems interact with each other? Now we're working at a bigger level. But unless we bring these things up into that level of things like systems, they're just going to remain facts that students memorize. So in order to do that assessment, here's some, that's just, we can go to the next slide, Chris, that should be taken off. We have to work and remember there's some things we have to then teach at the surface level, the deep level, and the transfer level. What is it that students already know at the surface level? Do they know how to make representations? Do they know what systems are? Do they know what components are? Do they know what interaction is? Do they know what the celestial bodies are? We can do some pre-assessments to find out what they know and what they don't know. Then we teach at the surface level to introduce it so they become familiar with it. Then we deepen it when we get to the understandings. We connect those ideas together and say, you know, in what way is exploration and knowledge in our solar system connected? Can you give me an example of how that's true? Let's examine it with another lens. Let's how does knowledge of the asteroids help us understand the interactions with Earth deeper? And so you just explore those understandings, and then we get to our final assessment, which is what I showed you, which is the transfer piece. It's, again, a novel thing they're doing, applying their understandings to something new. And given that, then what we're going to do is we're going to do a quick review here of some of the key things that were introduced at grades 4 and 5, so that when you're doing your grade 6 stuff, this is the, you know, you may want to find out what they know from 4 or 5 using some pre-assessments. And here's some, Chris is going to review with you some of those key things that they should probably be able to bring in to grade 6. So go ahead, Chris, I'll pass it over to you.
And so again, keeping in mind that they won't have the background knowledge, what you'll have to do is decide from how you're unpacking grade 6, what do you need? And you have access to the grade 4 and the grade 5 slide decks and the recordings. They will be posted. So grab what you need at this point. But what we did is we left in our slide deck the ones that we felt were probably the most relevant ones that you're going to have to kind of connect with and find out whether the students are familiar with those terminologies. So in grade 4, they talk about how objects in space impact daily life. So this is really just an introduction, although they talk about the universe, they talk about a solar system. They don't dive into that deeply. That's the grade 6 conversation that we're going to have about systems. So we ask them, even at that level, sort of what are the advantages and disadvantages of humans studying and exploring space? They may have very diverse feelings about that, and some might be very excited about it. Typically, space is an area that students love to study, so it's something that doesn't take you much to keep them engaged, that's for sure. So just having them work with partners, some suggestions about advantages and disadvantages that they might generate. But the key piece for them too is that they define what the universe is. So they start to learn some of the terminology that goes behind that. That the universe is everything. It includes it all. It's got all the planets. It's got all the galaxies. It's got everything is in there. It's the universe. They don't unpack the planets specifically because, again, this is happening here at grade 6. So they're always just kind of very much in the analogy I used in grade 4 was you're opening an umbrella and you've got this big broad umbrella open, and that's your universe, and you're kind of just teasing out what are the rungs that could be making up that universe that are holding open your umbrella, but you're not diving into any one of them with any great depth other than perhaps the parts of connections between stories and constellations and how that was used for navigation, that was used for all those two. So that's where grade 4 kind of drops its ball and does its work. So they talk about the sun, the moon, the planets. Yeah, they're aware of them. They do go through them surfacely. We talk about the difference between a notice and a wonder. And although that sounds really simple, we unpack that again in grade 4 just to say, have we ever taken the time to teach our students what a notice and a wonder is? So that if you're going to ask me in grade 6 to actually be someone who's going to design my own investigation, I have some good wonders already. I know how to phrase a wonder. I even know what a question might look like. So just that practice that might go along with it, suggesting how they might use an infographic to consolidate their thinking, to present some of the information that we ask them for. So again, we ask them things like, can you see the stars with our naked eyes? When you see, what do you see when you look up? We talk about if you have light pollution, if you're living in a city versus if you're out in a farm area where there's no light interference, different types of things that you're going to see in that night sky. Grade 4 also talks about what are some of the tools, just very surface level, but what are some of the tools that we use to see those constellations and those planets that are up there? So I can look up and I can see some things, but I might not see a lot of it because it's not bright enough, intense enough. So we talk about binoculars, that they actually could help you see something way more with your naked eye than you're seeing at nighttime. Telescopes, we talk about the different kinds of telescopes that there are, again, very surface level. And then we talk about possible locations that they could go to if they were going to just unpack some of this. So depending on where you live, TELUS World of Science, if you're in Edmonton, you've got the Spark Center in Calgary. You've got lots of virtual ones that are connected in the grade 4 slide deck. So you don't have to travel to necessarily have access to it. So one of the second understanding in there was that stars and constellations are recognizable. So do they know some of the constellations? Do they know some of the key constellations? Do they know how to find the North Star? Why was the North Star important? Why did history reference those constellations, and how did they use them over time to see where they were going? Throughout all of the organizing ideas, we have always been trying to find resources for you. And we've come across a couple of places where we have free access to an entire book, teacher's guide, as well as resources that go along with it. So in this particular case, given what the grade 4s were supposed to do, there's actually 2 books. The Sun and Moon and Stars comes from a grade 1-2 grade, but it actually fit perfectly with the grade 4 resources. The Astronomy Space Systems you're going to see again coming up here shortly in grade 6. It also filled in a good portion of grade 5. So when you come into this slide here, you can just click on the underlined ones, and that takes you to either the student, teacher's guide, or the resource. Resource system, the resource pages, you need to really spend a little time going through those, because those house way more than they look like they would in the first 4 or 5 slides. You need to kind of be patient and go through them. And there's a ton of resources in there that you can probably build your entire grade 6 curriculum from. Ted, you want to talk about these, why we brought these up again?
Sure. This is a page of links that you may find useful as you go through not only this organizing idea, but others. Each of those is a link to a short little activity that introduces those ideas there. Relationship, for example, and systems not on the revision anymore. It's just that each of those are really short quippets, and some of them are really basic. So they'd be used just to introduce. However, if you're not too sure your students understand these concepts, you could take the slide, take the end slides out of them, because the end slides always have practices, and you can change it just to use it for that pre-assessment if you're not too sure if students understand these concepts. I won't go through an example now. Maybe we'll go through one later on, Chris. But these are the important ones to look at, I think, for sure, once you're doing the entire new curriculum, because they'll show up all over the place, these words.
And they've been showing up throughout all of the sessions we've done. We were just became mindful of the fact that some people were saying, well, where did you find these? Like, where are these from? So we just wanted to make sure in your last one that you kind of have one slide where they're found and that you can easily access them. So again, we've got some resources for you that we can suggest if you're looking to build on your classroom library or your school library. This one is an EPIC book, which means that you could use it immediately within the classroom and you can just read it. You don't need to purchase it. So the hyperlink is there. And then we've also got some some links that you can go into if you're looking for further information about telescopes, different types, famous ones like the Hubble one, and how did that get launched and what did it give us, and that type of background. Again, this will actually become pertinent in the grade 6 curriculum when we talk about the tools that help us to explore space. So again, you might want to come back to this slide, even if you don't think they need to know it now or go review it. This might be one you want to grab and use for the grade 6. We also, as I talked about, you don't have to be able to go necessarily to a planetarium or to a science center. Wherever possible, we've included links in here, for example, the planisphere. I won't go into these just in the interest of time, and we know we have lots to cover. These are hyperlinked already so that the students can see the movement of the star sky over a period of time, over seasons, over the different parts of the year, so that they can realize that those constellations do not stay fixed in the sky and that they do change from season to season. And so this gives them that interactivity. And there's several of them in the grade 4 that are interactive in which you don't have to necessarily travel. Lots of videos for who created the constellations. If you need a quick review, this would be the one to start with because it really does unpack it well and it gives them a good idea of what a constellation is if they're not familiar with it. It even brings in the stories at the same time. Again, Starfinder. So all of these are interactive ones that you could use depending again how you're going to unpack some of those pieces. That'll be important for them to see. And then we talked about the legends that go along with the constellations in particular. The indigenous cultures had stories that actually named some of those constellations. And not every constellation, like we call it the Big Dipper, but every culture doesn't call it the Big Dipper. Every culture calls it something different and has its own story that goes with it. So again, you have these different samples that you could go through and share with the students or let them watch on their own. All right, let's get. So this is another one in which you can go in. The Night Sky Planner allows you to go real time. So when you click that on, it'll take you to wherever you live. And it will give you what's happening in the night sky in your location. It also will tell you what's happening in the sky charts coming up. Are there any eclipses? Are there any comets that you should be watching for in your part of the world? And then again, a virtual planetarium. If they've never been to a planetarium before, this is a great one because it takes them actually through the whole process of just as if you're sitting back in your chair and laying and watching the whole thing. So there's lots of interactivity in the grade 4 slide deck that you would be able to access if you just need to go back and do some terminology and some background knowledge. In grade 5, they talk about the astronomical phenomena. So we're talking about, first of all, what that is, and they need to understand what a phenomenon is. And these, Ted did a phenomenal job of hyperlinking. Every one of these are already hyperlinked. So if you just touch the borders on these, and it says you'll get some surface level activities. But really, that's what they're unpacking. They are unpacking the terminology associated with phenomenological observations and the objects that they see in space. And we want to know, like, what is a phenomenon of in this case, how does a comet come about? And they don't, again, get very deep about that. They're going to get into that now in grade 6. Want to know what the difference between a comet and an asteroid is, for example. So that will unpack itself in grade 6 even more. Okay. As we get into that astronomical phenomena, we're just talking about observable events. So I can see shooting stars, as they call them. Okay, I can see what those are. I have more scientific terminology that goes with that. So these events can be represented. How do we see them happen in our daily lives? And how did we see them in when time wasn't a wrist watch on our wrist? How did they do that? So how did calendars come about? Cycles of time, cycles of seasons, cycles of animals moving. All of those were indicators of time. The stories, legends, artifacts, the models, the digital simulations. So those are all how events could be represented. And so we would touch on some of those, the Gregorian calendar, the lunar calendar, like we'll talk about those in just a second. The events are predictable. What are the patterns and the cycles? And how did people who didn't have wristwatches know? Okay, auroras and eclipses, what's the difference between them? So they do talk a little bit about that and where would I see them and what would they look like? And what are the stories that go with those? Again, the events, the seasons, we review that. We talk about the length of a day and a night. How do we get day and night? How do we get seasons? So now we do talk about the tilt of the Earth on its axis and how that revolution around the sun and the tilt and our daily revolution of 24 hours impacts how much daylight we have, what weather we're having, that type of thing. And then the moon phases. And those moon phases and the work of the moon should come back into grade 6 at some point as well. So here would be some of those pieces that you might want to connect to it. So there are lots of videos that you could use. Some questions that we ask. How does the Earth's rotation and revolution contribute to day and night? So they have to understand that tilt. They have to understand there are 2 revolutions of both the world just going around in 24 hours, but then also our trek around the sun. And then what's the relationship between the Earth's tilt and its. We also talk about, can they perhaps do a model? Can they model how that would work? day and night seasons of the year. So could they take some styrofoam balls, or can they create their own model in which they would be able to demonstrate their understanding of how that comes about? There's a number of different links and resources, again, to help talk about that. We talk about the North Pole, the South Pole. We talk about hemispheres, the Northern Hemisphere, Southern Hemisphere. So that language is going to come into play and would have already come into play in grade 5. So they don't quite know those reference points. We might want to spend a little bit of time on that. And then again, just asking some questions. What are the relationships between the Earth's tilt experiencing the length of day and night? Or could they do that with a ball and a flashlight? Like, how could they show that to us? Something simple. Okay, how did the Northern Hemisphere and Southern Hemisphere experience opposite seasons at different time of the year? Is that true? And if so, can you model that? How would that look? So just to get a sense of what those are. Concept maps, as you've been seeing, Ted's always created a great concept map. Starts to unpack the specificity of what we're about to do in our organizing idea. But what if once we've taught some of that surface level language, what if we gave them some cards and said, how would you organize those? How would you put them together? So this might be a starting point. This would be a great starting point for you in grade 6 to give them those words and see if they even know what they mean and how might they put them together, and then ask them. It's not where they put them, it's how they explain to you the reasoning behind why they put them there, right? And so again, it's not the end all be all, but this could be a possible solution that they might come up with. Again, if they don't, why did you put what you did where? And that will help us to understand if they're not understanding, if they still are missing some concepts in there, then we can start there. Maybe they already know all this. Okay, maybe you've got an interesting crew that's already been doing space study on their own. And then exploring the moon in its phases, that's a huge component of grade 5. And again, we talk about tides and how tides get played into this. That too plays into grade 6. So this would be one that we might want to spend a little time on. There is a link at the bottom here, which will take you to not only the sky lore, but it takes you to great sites that will help to unpack. And this image actually comes from that site. So again, what are the phases of the moon? And how do the phases of the moon actually live in the language that we hear in the stories about Turtle Island and the stories that we hear about the different moons that arrive? So there's 13 lunar moons in the Indigenous calendar, and they all have a name. And each of those names actually, once you learn them, they're quite exact about the time of the year, about things that are happening. So when animals are migrating back, we have a name of a moon. When animals are leaving, we have the name of a moon. And it's reflective of what's happening at that time. So again, there are still people right now that are still using the lunar cycle. And obviously, if they're navigation and they're on water, the lunar cycle is important to them because it helps to explain tides and what they should expect. So this is just a quick sort of action question, open-ended question that we might give to students about what causes tides. What could they model for us that would explain to us, that would tell us that they understand how the lunar pull is affecting our tides. This activity that you're seeing here comes from the grade 6 science book from Newfoundland. So we had one of the publishers, Nelson, share with us the books that were being used in other provinces for science. And this one was a really great match for space in Alberta. So this is where we got that information from. Here's the information on the lunar calendar, and here's the lunar calendar versus the Gregorian calendar, which is our calendar that we follow with the 12 months of the year. And how do those two relate to each other? Like what's the differences? What are the similarities? So again, you might want to revisit some of the cultural stories that go around the lunar calendar. There are some links that you'll find here. There are some transfer questions. In other words, some summatives that you might want to even think about if they're ready. What is the relationship between the lunar and calendar and the Mackinac? So the story that Wilford will tell you, or the solar and the lunar calendars, same thing. So again, those are great questions for us to ask, keeping in mind that the Indigenous culture has names for each of those moons. So it is a very strong link for their stories as well as their day-to-day routines. Northern Lights have all kinds of different stories. So here are some of them here. So you can have different ones, even from different Inuit societies and different locations across Canada or into Alaska would have a slightly different story than their neighbors might have not too far in the distant future. So again, there's some story links for the auroras or the Northern Lights and what they are and explaining some of those pieces. And so again, we talk about how are the legends to astronomical phenomena? What have you heard? What do they know? Some students might even have them. If you have students that have come as new students to Canada, ask them what their stories are about the star cultures or the stars that they see in the night sky. They're not going to be the same as our Indigenous cultures, and they're not going to be the same as ours. So it'd be interesting to hear what they have to say. And then again, the star stories that are some of the key star formations that are used in navigation and used in just life scenarios are centered on this slide here. Okay, so you've got lots of resources, way more than you probably will ever want, but just to give you a really good sense of what is available to you without having to go search for a whole bunch more. So you have another set of additional resources. If something at the front didn't happen or didn't meet sort of what you need, you might find them in here as well. Okay, possible transfers. Maybe we do something like another, in this case, a spectrum sort. So I give them the cards and we ask them to look at what's the least and most impact on Earth. And again, where they put it on that spectrum isn't going to be as important as the explanation that they're going to give you and their rationale for putting it where they did. So what was their thinking behind putting it there? Why was it meaningful for them to have it there? And again, is there anything there that's a misunderstanding, or is it really sound and they have really good thinking? Anything you want to add to that, Ted? Okay, when we look at some of the understandings, again, observations and interpretations of astronomical phenomena inform daily living. Okay, that's that big statement. And as sort of Ted's been talking all along, we could take some of those statements and just reword them even to good questions. And then if they've understood those big ideas that we've been teaching them, then they should be able to make those connections. So what's the relationship between observations, interpretation, and astronomical phenomena in daily living? So again, it's just a flip of this, but now it's asking them to unpack it from a meaningful perspective that they have, and what explanation would they give us? So again, we have some deep ideas here that you can use. I won't read through all these slides, but just so that you know, you have some surface level, some deep level ones that you can use. Here's the link to the one for the lunar information. So that's an excellent one that you can go to. And then again, we have this resource section. There are some books that were written by Wilfred Buck and Melissa Purcell. Melissa is from Alberta, about the night sky. So again, these are excellent little books that you could add to your classroom, as are the ones that I'm going to show you now. And these ones also fit into grade 6. So the solar system one, we use some information from it. In this case, we looked at it from the 4 seasons. This fits into the grade 5, but the rest of that book is a grade 6 orientation. Okay, so grade 6 level, surface. Ted, do you want to start on this one and I'll keep going?
Yeah, I'll just maybe quickly point out this here. So Chris has covered all those things that are really important to grade as background information to grade 6 that they've learned to grade 4 and 5. You'll see that some of the what I've done here is highlight some of those key concepts that are used at the grade 6 in the grade 6 organizing idea of space, and some of the skills and procedures that show up in the skills and procedure statements. So the links are there to say, well, if I'm not too sure what a system is, I'm not too sure if my students understand these other things, those are there to introduce the students to you. Or as I mentioned before, we'll just open one as a quick example, Chris. You can take some slides out of it and turn them into some ideas. I'm going to just go to system, for example. So if you're not too sure, students know what a system is, you could do some pre-assessments by using the slide backwards, in a sense, beginning with the end slide and then moving forward. But what is a system? So we give examples and a non-example of a system. We just give one here. And often when dealing with concept, providing an example and a non-example is a good way to help students figure out what are the attributes. So by looking at this, they hopefully can find out what it, or at least start formulating an idea of what is a system. And you can see the bottom image there just has a bunch of components. And in the top one, there's components working together, which really identifies three key elements, not all the elements, but three key elements of a system, which is the next slide, I think, Chris. Yeah, it's just a group of parts that move together and are connected to achieve a certain outcome. An outcome is one of those, again, one of those key concepts that is in grades 4, 5, 6 computer science, that when we make algorithms or design, we have an outcome that we want. So those are the three things of what a system is. And then the next slide just have students explore what a system is. So if we can go through those, how can a person be riding a bike be considered a system? And if you think your students at grade 6 already understand the system, just give them this as a pre-assessment. Can they do this? And if they can, you've got some good information. If not, you're going to back up and help them understand a little bit more what a system is. You could just give them some images. What systems do you see here? Can they identify examples of a system? If not, it's time to go back up, review it, and make sure they understand it, because we're talking about the solar system here, right? And all the components in the solar system that work together and interact. So we're looking at here. So most of those activities that you have are short like that I had on that list. And again, you could take, if you think your students know it, work from the back slides, use it as a pre-assessment. If they can't get it, then go to the front end and go through the activity with them.
So if we could look at just some of the things that you're going to have to unpack with them in grade 6. I'm bringing this back again. I know it's a bit of a jumble, but I just want to go back to where we started and that importance that Ted pointed out to you earlier on in the cusp that you saw. We had that yellow highlighted area, and that was really to tie in the fact that it was systems that we want to look at. So this is not about how many different planets can they name and memorize every fact about every planet. That's not what this is about. They have to know the planets, yes. And none of us are going to walk around knowing all the aspects and intricacies of any one of those planets. But how is it that they work together? Why is that important? Why is Earth in its position where it's at in location and in reference to the other planets around it? Why is that important in the system's big picture? That's where we want them to be able to go at some point. So yes, they do need to know the foundational pieces for sure. I need to know what a sun is. I need to know the planets. I need to know the difference between a dwarf planet and Earth. Like, how are they different? What's the difference between an asteroid, a comet, and a meteoroid? So what are the differences? And can they name them? Can they find similarities? Can they find differences? So these are the two pieces that we want to unpack with them. But really, we're keeping in mind, how do we explore the solar system? Like, how does that system work together? So keeping that in mind, that's the reason I wanted to put it there. I just want to revisit a little bit of what we looked at the front. So yes, we're going to unpack technology. What are some things that we use right now to help us explore? We've got Artemis getting ready to be launched and going, although it's delayed a little bit. That's going to be a whole new space exploration for us. Why do we want to explore space? How do we get telescopes further into deep space so that we can get more pictures? How do we get the pictures that we did? So students need to understand that telescopes don't just sit on Earth. Some of them are launched into space. And where are they now? And how are they staying up there? And what's the plan for new telescopes? So students who are interested in that area of exploration, can they design their own little robot rover following an algorithm where it does what it's supposed to do? Can they give it some rough terrain where it's got to go over? Maybe it's on the moon, or maybe it's on pretending it's on Mars. And can they do that? So there's your computing science built right into this whole idea. So lots of different ways that I can include the technology into this piece. We're looking at the difference between those natural satellites and the ones that we send up that are man-made, right? There's differences there. The moons, the different moons of the planets, why are they important? Why do we even care? What about asteroids? Why do we care about the asteroid belt? What happens if there's an asteroid that comes near Earth? Do they know what happens? How did we get craters on the moon and not on Earth? Or do we have some on Earth, which we do? So again, do they understand that? So there's an activity in here for them to even develop a crater of their own to get some idea of what kind of questions might I formulate if I was going to do an investigation. And then here are the pieces that we want them to understand about each of the planets, but not to memorize, right? That's not the purpose of where we want to go here. So the universe unpacked, our place in the system. This is your link at the bottom, Study Jams. If you're not familiar with that, I won't go into this one, but they offer you not only a quick video, but there's also a quick quiz in there that the students can do at the same time to test their own knowledge. So it's a fun place for them to be, but it's a very timely one. We're looking at really unpacking all of those celestial bodies. So what do they have in common? Which one of these celestial bodies, once I know what they are light emitters? Like which ones send off light? Which ones reflect light? There are different kinds, right? They're not all just a star up there that's a white and just shooting off energy. They all have different shapes. Comets and asteroids are different shapes. Meteorites that come down to Earth are different shapes, sizes, right? Compositions, surface conditions. So we've also built in a sample in here where students might want to even find, if they could find a meteorite. Then we'll talk about that in just a second. So how did our solar system form? This is, if you want to start somewhere, I'm going to say to you, this would be the place. Start with this Astromate. It is an excellent, excellent starting point as far as understanding how our solar system started. It will give them great background. It's not going to get them to memorize planets, but it really does get them to understand, or at least give them a starting point on how do we answer the question, how did our solar system form? And it will help them to understand those subsequent questions that we're about to ask them. So the planets' names, there's a quick sort of mnemonic at the bottom if you want to remember the order that they're in. Some students love mnemonics, some hate them. I mean, whatever works for them. But in this case, my very easy method just speeds up nothing is an easy way for them to remember. There's a link here if you want to go into the memory pieces of it. The next slide is one that is interactive. So I just want to show you how it works, but not to spend time on it. If I want to get some just basic planet information here, I see my planets in the order that they appear. Every one of these is hyperlinked to its own information. So when you click on the planet, whichever one it is, so each child can have a different one, it gives them just a quick overview of some of the things. And then if you want me to go a little bit deeper, now I've got some research that I can put in. You can come back to the main slide by just clicking on that bottom one that takes them back here again. So every one of these has its own slide, and it will let you come back and forth when you're using the slide deck as well. The solar system's orbit, how do we fit into that? So we saw how they fit in order. How do they fit as we start moving around? And obviously they're not all moving at the same speed, and their orbits are all different. Some of them go through one of our so-called solar year, or one of our years. Some of them can go around more than once, and some of them only go a fraction of our year. It takes them many of our Earth years to go one cycle around the sun. So again, that's just understanding how they maintain their orbits and how they go through that. This gives the students a better idea too of how the planets are in relative size to each other. And we're pretty tiny. I mean, we're not much to speak of when we look at some of our neighbors that are sitting beside us. And again, the size of these is impacted by some of the things that are happening from gravity. It's also talking about the formation of the solar system. It explains why some of these are the way they are. So that first video that I mentioned to you, good starting point. So again, when we talk about, we said there were some light emitters. Once I understand what some of the different natural bodies are, what is a light emitter? So first of all, I need to know what that is. And what's one that reflects light? What does that mean? Again, so we have these pieces in here, relate the characteristics of a dwarf planet to the reclassification of Pluto. So once I know what a dwarf planet is, and once I know something about Pluto, now I can make a connection between how were they the same, how were they different? Why did they reclassify it? What was it about that? Crash course in anatomy is a great one as far as talking about how the waves move and sound moves. and also the intensity of light from the sun. We think the sun's super hot and it must just be blowing up all this energy from the inside out. Well, it's not. It takes a, hundreds of billions of years for one little energy particle of heat to come to the surface of the sun. Not that long to hit the earth, but to get to the surface of the sun is huge amount of time. This is fascinating for kids to watch.
Welcome to this.
Again, here's some terminology that we can do, but again, we're not here about terminology. They have to understand it before you can ask me to connect it. That's going to be the big pieces. And then we can talk about the differences between comets, meteors, asteroids, meteorites. Those pieces are in here as well. And then we'll get into some of those activities that I was mentioning before. Right, when they're hyperlinked, they just all want to start at the same time. So you have two slides here that you can use. If you want the students to have a little bit of, just a little bit of an investigation about, are there any meteorites around my place where I live? Most kids will say, well, no, I didn't see any rocks fall out of the sky. But in actual fact, they're falling from the sky continuously, just in microparticles. And so this is pretty fascinating for the kids to realize. This is a video, or a still reading component on how to collect them. This one goes through how to go find them on a rooftop, and it actually shows the study that the people did. We want something a little bit more simplistic, a little bit more down to earth for the kids. They can go up to the gutters, they can go down on the street, they can put a pot outside for a couple of days. This one allows them just to take ordinary pot from outside, even with rainwater, and lets them collect it to see if they can find some meteorites. It's a nice little activity for the students. It comes from that solar system book that we talked about. And then again, comparing and contrasting the natural from artificial satellites. So we have natural satellites that occur, but we also have artificial ones that we're putting up there. One of the questions we might ask students is, are we putting up too many? Is there garbage in space that we should be concerned about? Okay, it's a good question for them to think about. Solar system exploration, another one. This is very current, and it takes them to live action for each of the planets. And here's a great sort of comparison that I might want to do, leaving it open for them to choose what it is that they wish to do. What bodies do they want to compare? Do they want to do planets? Do they want to do a planet with an asteroid, a meteorite, blah, blah, blah. And then an infographic. I want to talk about this one, Ted, because this one is an important one for a lot of the things that we've done.
Sure. If you recall, the assessment piece that I had at the end is creating an infographic that demonstrates or helps to explain why the solar system can be considered a system. And so this is an example of an infographic here, just for an example of the infographic, but it just happens to have the three components of the three key characteristics of a system. I put this one together from Canva. Many of you are familiar with that. There's a free version of that available to make infographics. There's lots out there. And Common Sense Education has a bunch of different design apps. Some of them you have to sign up as a teacher and so on, investigate them. They can help students to create infographics. And what an infographic is it's again a graphic representation using words and pictures and often arrows and things to provide a lot of information with as few words as possible and as many with words, but not as many, not too many, and of course graphic representations as well. So there's a nice little explanation about what an infographic is here and some examples and then elements again that maybe can be turned into a rubric for assessments and so on. So there's lots of information here. We'll go to the next slide. Again, if you're going to introduce it again, I wouldn't have suddenly students say, okay, we're done the space unit now, you're going to make an infographic. At the surface level, again, you want to know from the kids how much they know about an infographic, how much they know about an infographic, what it is, have they made some before? Have them practice making some fun ones at the surface level. Typically at a surface level, you want to give students practice with a skill or a procedure that doesn't necessarily have content from the course, so that they're not responsible for the content and they just focus on the process and so on. Once again, when we're designing and making something like an infographic, at the bottom I have that connection to computer science and that design thinking. Really, when you think about it, if they're going to design an infographic and make one, they're going to be really understand the problem. Who's going to be reading it? What's the purpose? Who's going to see this infographic? What are some ideas, maybe different templates, and look at all kinds. How can I change this template? You're going to plan it, and then they're going to create it, and then they analyze it. And if they're going to analyze their infographic, again, there's going to be some criteria in that self-assessment checklist. Does it have this? They're looking at it closely to see if it has those things. And maybe if you're going to test it, as design thinking does, maybe doing some peer editing or having students look at it for review and then making some troubleshooting, revising it, and then finally handing that thing in. So again, an example how we can bring in that all the big concepts together with one of the key skills in the science program is representing information, and again using design thinking to bring it all together. But again, this is a summative assessment, so you want to make sure students have had practice in working with some of these things before they're given one for a final assessment. Other ways you can represent are comic strips, mind maps, and a whole lot of things there. I'm sure you're familiar with many of the ways to represent. There's an interesting comic strip one. We won't click on it, but it's got some blank templates and it's kind of got an AI kind of a feel to it where you can add in backgrounds and of course thought bubbles and speaking bubbles and so on for students to demonstrate what they know through a comic strip. So that's all a representation is. And next slide just adds one more piece of information for representations. That quite often we want to use some non-linguistic ones as well for that whole differentiation piece. But often students can express their understanding non-linguistically through images, through forms, maybe through movement and so on. So if you're thinking of allowing that to happen and looking for more of that, there's some tips there to keep in mind if you're going to have students do non-linguistic representations. I just want to speak a little bit about discussing. Yep. Discussing shows up lots, as you'll notice in that summary of 4 to 6 skills. The most commonly verb that showed up was the word discuss. Because really, when you think about it, if you're sitting in discussions, and Chris mentioned have kids talk about it, speak about it, you're doing a lot of formative assessments by listening to what they're saying or what they're doing in a discussion. But all too often, we just have we don't want to be in that position where we're just going to have a free discussion and hopefully everyone will get a chance to talk. We'll want to make sure that students are engaged and involved in discussions. And the bottom half of the slide shows different discussion formats that are really helpful to make sure that students become involved and to hear from everyone. As well, I have some at the very top of Div 2 checklist. If you're not too sure what students at Division 2 should be able to do during a discussion or be able to demonstrate during a discussion, we've created a checklist there for you that pulls out things from the competencies. So it's just a checklist of what students should be able to do. And again, like any skill in terms of discussing, you want to give students some feedback. You want to work at the surface level and bring it explicitly. We're going to learn about what a discussion is and what it means and what are the skills, and go to that checklist and practice those things and give students feedback in it. We can establish those things early and get the groundwork for good discussions. All these examples of these formats can become very powerful, not only learning tools where they deepen their understandings, but really powerful assessment tools for you as a teacher as well. And there's just some links there if you want to, because one of these skills and procedures was discuss the reclassification of Pluto. There's some information to help you with that. And you know that, again, we're talking about that assessment piece that I had where students are going to create a representation that explains why perhaps the solar system can be considered a system. Well, anytime you're talking about a system, we're talking about interactions. And there's some possible interactions that kids can explore during this, the surface and the deep phases of their learning to say, well, what's interacting with Earth? What are some things out there? So that's just there as a reminder of all the interactions that do take place between Earth and the celestial bodies in the solar system. Again, just a spectrum sort that was like interesting to, I think, Chris, we already had this one maybe. I think it was impact on Earth. This one's, we could do a spectrum sort by changing the bottom piece here. The other one was do a spectrum sort, and the key was the impact on Earth. In this particular case, most interesting to me. So now they're going to be talking about evaluating, and that's, again, one of the skills that show up. And, you know, it'd be interesting to see what criteria they used to decide what is interesting. And it's just another activity for them to demonstrate and deepen their understanding of these specific things here.
And so again, craters is one of the things that they talk about. It's some of the things that we can have impacts on Earth. It can have on our history. When you go back and look at how the solar system was formed, they will talk about craters. They'll talk about interactions and collisions that happen, and where collisions are near but not actually happening. So this is a neat little activity investigation that the students can do to see how I could recreate making a crater. And it's just as simple as taking a pie dish and some of the things that are in there. So again, it's something that they could, if that's an area of interest for them, they could get a sense of how this works and how it doesn't work. There's a video in here as well, which shows the actual building of a crater. And again, it's one of those things where a teacher's just modeling for them how they might build a crater and how they wouldn't, and what's those odds that we talk about, hit and miss, that they're not always a surefire that it's going to land in a certain place. All the different things that can come up. So these are the slides that are connected to the planets. I'm just going to go through them very quickly. So those are where those are hyperlinked. And here's where you find some of the things that we saw in grade 4. We pulled them back in again because these are some of the tools that we want the students to remember that they can look. Now we've changed a little bit of the connections at the bottom here, because when we talk about the rovers and the lunar landings, and we talk about going to Mars, and we talk about how do we get the pictures from Mars and how do we get the pictures that we do. So again, talking about this, and then our Artemis 1 flights, what's the purpose of that? So for students who are really interested in furthering exploration in space, this will be the area that they want to spend a bit more time in, just to make some connections, because now, they could even be designing their own little rover, as I was saying before, where they could use some of that computing science at the same time. So asking a conceptual question, transforming the understanding, we talked about that before, into a question. We've seen that, how that works. We might want to talk about how do some of the things happen in space. What was Canada's contribution to the space? I mean, that's a sort of a diversion of it, but it's part of it. We're sending astronauts up into space. What was our role? What is our role? What have we contributed? So we have the Canadarm. We talk about that. We don't have telescopes that look like this anymore, but we have some that could be refined and used in some of those regards too. Some of them do look like this, but they're a lot larger. And what is it that they show? What do students experience with telescopes? If you have a parent, if you have a student who has a telescope at home, have a telescope night so that they get an understanding of how this works. Okay, making the concept map. This is the same idea, taking some of those key concepts that exist right now in grade 6. And how would they organize this? Again, it goes back to it's not where they put it on the paper so much as how they're going to explain to you how they were connected on the paper that made sense to them. And is it making sense? Is it logistically correct, or is there some shortfalls that we want to look at? So again, create a representation that helps explain how the solar system can be considered a system, is where we started. That's your kind of your end product, your surface, or your summative piece that you wanted the students to have. What knowledge have they gained along the way in order for them to engage in that question? And if you've got some high flyers, this is a big one. If you have some high flyers that love science and they can see those connections between systems, this would be a great challenge for them to get into and just see what they come up with. Okay, do you want to talk about this one, Ted? Or
Yeah. And I just added this as we're on that assessment piece. And again, just a reminder that when you're creating your assessment pieces, whether they be formative or summative, it's a matter of choosing those key verbs that you want your students to do. And they probably had practiced many of these by the time they get to the grade 6 level. So just know that there is lots to choose from to really get them to demonstrate what they know and understand.
And so you see, we've taken out the pieces that don't really relate to anymore from the grade 4 and 5. This is kind of what's left. These are the areas in this section that you would be looking at. And I've already hyperlinked those systems in space that help us from a technological perspective. These are all hyperlinked for you already. And they're all short videos that show the students a rover. They show them a satellite, how it gets launched, so that they have a better understanding. And that's why I say when you go into this resource link one, you really need to scroll down. It looks very vague at the beginning, but keep going to about page 4. After page 4, you will see the specificity of everything kind of pop out that you need for grade 6. Not that you need more videos, but it just might connect some of the pieces that students might need. This is all about the International Space Station. Again, because that's part of, they're up there, they're closer to, they're living and they're working in space, and they're carrying out things like, how do we grow plants in space? That's one of the books that we have for you as well. So how does the International Space Station help us to further explore space? What are their goals? So again, this is just on the International Space Station. There's lots of places that they can go. And then Let's Talk Science, space exploration talks about how do we launch some of those things into deep space? And what is our hope? And why is it that it takes so long for them to get where they're going? Those types of things. All right, told you there were lots in this one. So here is an activity. Again, it comes from our grade 6 science from Newfoundland. How have Canadians contributed to space exploration? What's our role been? And what is our role to be in the future? We have astronauts going on the next mission. What's their role? What's their job going to be? What is every astronaut goes up has a specific role that they're going to play. So again, conceptual questions. In what way does knowledge of the solar system continue to develop with further space exploration, discovery, and the use of technologies? So it's just taking that understanding and changing it back into a question again. So you could use these as deep questions. You could even use these as summatives, depending on what you've done, what the students have done. So additional resources are what's coming up now. You've got lots of them that are here, lots of them that are hyperlinked. And you will find that, again, these are very interactive, most of them, and they're very current. So we're going to keep going. We've got solar system. These are the books that I was referring to. These are excellent books. Every one of these is available from Pearson, but they're also just great little books that are excellent for our current new grade 6 science. So a lot of them that are here, descriptors are given to you beside them. So that you have a sense. Talks about living in space, growing things in space. If we're going to have people living on Mars, what would that look like? Would they be able to have enough food? That kind of thing. And then, as always, Ange has created for you a slide deck that links the computing science to the grade 6 space organizing idea, and created a video as well. But she's also done an excellent job of creating a CPAR document. Do you want to talk about that, Ted?
Only in the sense that a CPAR document stands for the Curriculum Planning and Assessment Resources. What it does, it breaks down the organizing idea into the cusp lines, and it provides learning activities that are associated with the information in those cusp lines. So lots of good examples of how to integrate that into your course. So you might want to look at the overview of computer science if you haven't done that with that first one, and you work your way down into those specific things in the CPAR, and then those video and slide deck at the bottom.
Okay, and so our last slide. Way to go, Marilyn. You hung in there with us. We really appreciate it. So we're talking about here is the assessment that we had mentioned when we first started our sessions this year, that we had made a decision that we would get together with teachers who were interested, work on assessments, and we'll define what that's going to look like, whether you want more traditional, you want them by organizing idea. Some schools need a summative. It covers the whole year. Some don't need a summative for grade 6. Everybody's different. So we have this registration link is here. It doesn't cost anything, but you would need to be available for the 2 days, because we're going to work. We're just going to work together and put together all the documents that you need, so that by the April 10th, hopefully you have a draft that you can use, and maybe even use if you're piloting this year, to see how well that works for you. So that is the end of our science curriculum. I'm going to stop our recording.